Good afternoon and welcome back to Tech Days Online. My name is Marcus Robinson, a technical evangelist at Microsoft here in the UK. And the last session of the day, we've got Elton Stillman here to join me to talk about Windows containers and Docker. And just before you start, remind you, any questions about anything that Docker's, anything that Elton's going to talk about this afternoon, please do tweet us using the hashtag TechDays. We've got a team of guys in the back and working away to answer your questions.
They're ready to go.
So, off you go, Elton.
Yeah, hello. So my name's Elton. Let's flip to this so you can see who I am. I'm an Azure MVP. I've been an MVP for 7 years now, I think. And I'm also a Docker captain. So that's the kind of the equivalent of the MVP program for Docker guys. So I've been using Docker for a while, and Docker gels really nicely with the move to DevOps. So this session is about how the tooling can help you make that transition to DevOps. So we'll just get stuck straight in. So I know that the tooling is only part of the approach to DevOps, is only part of how you get there and how you accelerate and take all the benefits. But actually, it's somewhere. Docker is somewhere where the dev and the ops teams can meet perhaps for the first time. So Docker is a really simple technology. It's simple to get your head around. It's massively popular. It's been hugely popular in the Linux world. It's taken off hugely in the last few years. It's only 3-4 years old, the technology, and it's coming to Windows soon. So you can it's going to be coming in Windows Server 2016, which is going to be launched in 2 weeks' time at Ignite.
I believe so.
Right about then. So you'll be able to run containers natively. So let's step back and what is that stuff? So Docker is an application packaging technology.
I thought it was a company.
Yeah.
Let's get this straight.
Yeah, let's get this straight. So Docker is the name of the technology, and Docker Inc. is the name of the company. So it's an open source product that you can go onto GitHub and you can contribute to. But there's a commercial company who provides support and that sort of stuff as well. Very similar to other models in the Linux world. So Ubuntu with Canonical and Red Hat. So you can use the software for free, but you can pay extra to get support. So that's Docker Inc. and Docker is the technology. So it's for packaging applications. So I'm talking to you as if you don't know, but I know you do know. So you can take your application and you can build it up into one single logical unit, which contains your app and all its dependencies and the platforms, that might be .NET or Node.js or whatever, and all its dependencies, and even the operating system, and have one logical package, which you can throw over here and throw over there, and anywhere that can run that image, Docker call it an image, can start an instance of your application. And it'll be the same everywhere, whether you run it on your laptop that's got 2 gig of RAM, or whether you throw it up to Azure and run it on a super high-speed VM, it'll be exactly the same code running in exactly the same way. And that's why it's so powerful for a transition to DevOps, because that image, that packaged image, is the product of your development cycle, whether it's just adding a new feature or whether it's a 2-week sprint or however you're doing that stuff. The outcome isn't just isn't a zip file or an MSI which has a whole bunch of instructions to go with it. The output is what you're going to run in your next environment. So it's somewhere where dev and ops teams can meet together. So I've got a few slides. I've got a couple of little demos, so we'll go through and feel free to chip in because we have lots of experience just in this room. So you take that idea, if you take your .NET application and you build your image, so you can do that manually or you can do it as part of your build process. So as you kind of get further on into the Docker world, you'll have an automated build. It's all command line driven, so it's all very simple to integrate with the new TFS and all the sort of stuff we've seen so far today. So the outcome of when you commit your changes and you push them to your source control, it will build the application and it will package it up in that image, which can be versioned. So then I've got a version of my image that I can run anywhere. And when I run it, what I do is I start a container, and that is an isolated environment where my application runs. It's the same code that I would have tested locally or tested in my test lab and then pushed out to production or whatever, but it's exactly the same thing. It's in a little sandboxed environment that's very lightweight. So on my laptop there, I might be able to run, maybe if I was running VMs, I might be able to run 2. This server's only got 8 gig of RAM, so I can probably run 1. But my containers don't necessarily have to have a limit on how much memory or processor they use. So I could run 10 or 20, as long as they don't all peak at the same time. It's just like running a process. You can throw as many as your machine can handle. And when you're ready to go to the next environment, you just take that same packaged image and you push it up to anything that can run Docker on a compatible operating system will be able to run that image. So it's a really nice way of the output of your development work is that image.
And you know, if you run it on your machine, you know, I'm running it on my machine, when I get it up into production, it should execute in absolutely the same way.
Exactly. So you were taking out. So it's especially useful when you're looking at problems and diagnosing problems, because you don't have to take a cut of code from some branch from whenever and try and recreate the environment and deal with the fact that maybe your dependencies have moved on, maybe your operating system's moved on. You just get the image that's tagged and saved somewhere, and then you run that, and you can hopefully replicate an issue. So it's really good for that, and it's also really good for eliminating the potential problems. So I mean, going back way back when, there was you could get issues when you ran your ASP.NET website, that Windows Server behaves slightly different from Windows Client because they were different code bases. You eliminate that problem because you're running the web server is part of your container as well. So we'll have a little very quick demo of the obligatory hello world, and we'll see what a container actually looks like and how you build it, because that's one of the key things for a transition to DevOps. So your Docker image, I don't think I'm in, let me get out of presenter mode so you can see. There we go. So your Docker image is a binary. Logically, it's one binary file that contains everything. But you build it from a text file, which has a very simple domain-specific language called a Docker file. So this is a perfectly valid Docker file. And all you have is, the minimum you have to say is which image you're basing it from. So that could be something as simple as a really thin Microsoft Nano Server image, which is what I've got here. And then I'm specifying the command that gets executed when you start a container using my image. So Microsoft Nano Server is a public image that Microsoft provide on the hub. So Docker Hub is a central registry which is free to use, which is run by Docker Inc., where you can get a whole bunch of, there are thousands and thousands of images on here, and it's hugely popular. I think they hit something like 5 billion pulls so far since it started a few years ago.
So when would you get an image from Docker Hub, and when would you create your own using a Docker file? Absolutely,
good question. So if there's a matching image, then and you can trust it, then you would use the image from the hub. So this is Microsoft's user space on the hub. They've got a whole bunch of things on here, most of which are base images. So I've got an ASP.NET base image, which has got Windows Server Core, it's got IIS, it's got ASP.NET ready installed for me. But on its own, that's not going to do much for me, because that's just going to give me a default IIS page when I start it up. So I would use that as my base image, and I would layer on stuff on top, which we'll see shortly. But some of them are pre-built images. So like OMS here is a container that you can run that pushes information up to OMS in Azure. So that's a ready packaged container. There are different types of image. Some are meant to be built on, and some are fully packaged applications.
So you used an interesting word there, trust, earlier on. Do you trust? So when I talk to people about containers, and I say you pull images from the hub, they say, how do I know what's in that image? How do I know someone hasn't tampered with that image? What would your answer to that question be?
So on the hub itself, the hub is a public repository, so anyone can set up an account and upload an image. You could build an image on your machine and upload it, and it could have a keylogger in there, it could have anything, and it could be claiming to be something else entirely. But there's another type of image which is another type of image on the hub, which is automated builds. So some of mine, that's my smiling face there. Some of mine are automated builds, and what you do in that case is you link this image definition to a GitHub repository, and every time I check in, Docker's machines pull from GitHub, build the image, and make it publicly available. So I can't upload an image here. So these tags for my images are coming from when it's been built by Docker. So every time I've checked in, it's done a whole bunch of stuff, and it builds the image for me. So I can trust that because I can go over to my source repository, and the hub tells me what it's using. So in this case, it's going to this Hadoop.NET image, and I can go and look at the Docker file. And I know that what's in the image is what's in the Docker file because they are built, they can't be tampered with.
So it's important that we check where our images are being built from.
Absolutely,
if we're using images from the hub, that we check where they're coming from, and that there's nothing suspect inside that we might not want in our production systems.
Absolutely, but in production, as you the hub is where you start when you start with Docker, but as you kind of move down the journey, you can run your own registry in your own premises.
We can come on to that later.
Yeah, we can come on to that a bit later on, but then you have an extra layer of security because it's your own area. So just because you've got you haven't got an automated build doesn't mean it's not trustworthy. So none of the Microsoft images that use Windows are automated, because all of Docker servers are Linux servers, and a Linux server can't build a Windows container image. So there's no way for Microsoft to link this to build. So these are automated because they're Linux based, but the ones which aren't Linux based, like Nano Server, that's a Windows image. There's no mixing kernels. So if I've got a Windows container, I have to run it on Windows. If I've got a Linux container, I have to run it on Linux. Maybe that would change, but at the moment that's the way it is. So here's that Nano Server image. That's the new, really cut down version of Windows Server. It compresses down to under 400 meg, which is important for coming back to the security idea. It's got a very small attack surface. There's a limited number of tools built in just so you can use it as a base layer. So you wouldn't necessarily, in the container world, you wouldn't, if you had something running in production, you wouldn't necessarily connect to that container and expect to do things like, ping or look at files or anything like that. So Nano Server doesn't have the MSI platform, so you can't run an ordinary installer on there. So you can't run the full .NET framework. All it's got is PowerShell. But anything you can do with PowerShell, like download files and install them, you can do with Nano Server. So it's ideal for new greenfield stuff like this very important Hello World app. And so all I'm doing in this Docker file is saying, this is my base image, the Windows Nano Server image. And when someone starts the container from this image, I'm just going to run a line of PowerShell to say hello from Windows Server. And to build that, it's just that there's a Docker build command, which just looks a bit like this, and you give it a tag, which is a unique identifier, which is if you push it up to the hub, that's what it'll be.
It's like its name, I guess.
Yeah, exactly. But it could have a version in it as well, so you could use that as your versioning mechanism. But I've already done that, so it's up on the hub. So I can just say Docker run // what do I call it? Nano Server Hello World, I think. Now, if I'd never run this before, it would pull the image from the hub, and then it would unpack it, and then it would execute, start an image which would go into that command entry point instruction and run the command to say hello world. I've already got it, so it doesn't do the download, and it just says hello from Windows Nano Server. So that's all that container is going to do. So there are different types of container. This one doesn't look useful, but actually it's what I call a task container. So it's built to do one thing, it executes, and then it finishes. And it's gone now. So if I run Docker PS, which tells me all the containers that are running, there aren't any because it's finished. Doesn't look useful, but that's ideal for things like infrastructure as code. So instead of having a whole bunch of PowerShell scripts and requiring a host environment that's got the right version of PowerShell installed and all the right modules, I could put all that into an image. And if someone wants to create my test lab in Azure, they just do Docker run test lab, and it would go and make all those calls for me. So it's a really nice. The task container is one really good pattern. And the other types of container, there's interactive containers. So you could start a container and then connect to it as if it's a remote machine and do whatever you need to do, which is useful for when you're building up an image. And then most common is the background container. So you start it, it sits in the background, and it listens for web requests. So it's a web server, or it's listening on a message queue, so it's going to handle messages.
Like a service.
Yeah, but like a background service, exactly. So that's the simplest kind of image we've got. So let's skip back to see where we can start getting some more use out of this stuff. So that Docker file was really basic. You wouldn't have anything as simple as that. In reality, if you've got an existing .NET application, and from now on, I'm not talking .NET Core or Linux or anything like that. This is Windows with ASP.NET. You would have, if you were installing a new version of your if your app will go into a new environment for the first time, you've got a whole bunch of steps like this to follow. So you might say, right, we need to start Windows Core, install IS, install .NET, copy in the application from somewhere, and then set it all up by creating the website. And if you were doing that in a VM, the output would be a virtual hard disk. It's probably 30 plus gig to push it around. It takes a few minutes to start, and it will only run on the hypervisor that it's built for. So if it's Hyper-V, only run Hyper-V, VirtualBox, whatever. That's fine, but that 30 gig is difficult to push around, really. And the fact that it takes a long time to start isn't ideal. And the fact that it's a full server operating system means it's got quite a big attack surface and a lot of stuff that needs to be updated. So you're going to get a lot of Windows updates going on in there. But if you've got an existing legacy ASP.NET app, that doesn't mean you can't start moving into the container world, because you can take that whole setup and make that into your Docker file. So I can take all those steps exactly as they are in a Docker file, and the output will be a Docker image. Now, it's not going to be the kind of ideal Docker image that's just a few hundred megabytes and starts in a second and all that sort of stuff. It's going to be a few gig, because we're still using Windows Server Core, because we need that to get the full .NET framework. But what it does mean is it's our first step in taking an existing application and potentially putting it into a containerized world where I could start breaking it down or start realizing some of those benefits of having a centralized image that defines my whole application. And then perhaps then I can move on to looking at breaking out one part of that application that changes very frequently, and I might build that into a separate microservice that runs on .NET Core and uses NanoServer and all that sort of stuff, and that will be a few hundred meg and start in a few seconds. And that's potentially the end goal, but you don't have to throw away everything you've got. You can start gently and bring these things in.
So you'd say use Server Core if we're perhaps looking at legacy applications that have prerequisites that are only available in full Windows Server, and then maybe new applications that we're architecting to run in the cloud. We'll be looking at moving forward once 2016 is released, use NanoServer.
Yeah, absolutely, yeah. So if you're greenfield, I would say, even now, .NET Core it's new, but it's very well established. It's had a huge amount of development. Version 1 is a very stable release. NanoServer, when 2016 RTMs, I think that's going to be nice and solid, and you'll be able to build your greenfield apps on that. .NET Core, it's not really a .NET Core session, but it's all componentized, so it fits very nicely with this idea of building a nice small image that you can push around anywhere because you only include the parts of the framework that you need. You don't have to install the 400 megabyte .NET framework. If you're writing an ASP.NET MVC, you include that NuGet package, and so you end up with a nice small final image. But it's not just a case of greenfield is NanoServer, legacy is Server Core. I think there's a path where you start by putting your legacy stuff on Server Core, and then you start breaking bits out. Because when you start moving to Docker, what you end up with is an infrastructure that makes it really easy to break things out. So you can start doing that fast deployment of things that need to change regularly, knowing that the other stuff isn't going to get broken because you're not touching it. So that's the kind of what I'm looking at the moment. So what I've been doing, which I'm going to extend as we hit Ignite and we get to RTM, I'll kind of finish this and I'll be blogging and tweeting about it. So I've taken Nerd Dinner. Do you remember Nerd Dinner? The old.
I've not come across.
You've not come across
Nerd
Dinner.
Oh,
you're obviously not
cool enough.
You're not as old as me. So Nerd Dinner was a thing. It was like a showcase application that some of the guys from Microsoft did years and years ago. So like the code was written by Scott Hanselman, Scott Guthrie, Phil Hack. Some people who've kind of moved on to do other things now. But it's an open source app that you can get on Codeplex. And it was originally ASP.NET MVC 3, and then they upgraded it to MVC 4, and then it's just kind of sat there on Codeplex for the last 3 years, and no one's touched it. So it's a classic kind of legacy app, and I was interested to see what you could do to see if you could actually run this in Docker using Windows Server Core. So that's what I've been doing lately, and kind of looking at see how we can actually make that happen. So I've taken a cut of the code, I've put it on GitHub, I've made a few changes to the code, not very many, just a few, and then wrapped them up in a Docker file. And my Docker file for that looks like this. So it's bigger, there's a few more things going on, but actually it's still not very complicated. I'm starting from IIS because that's an image that I can trust because it's from Microsoft and it's got IIS already installed for me. So inside the IIS image there'll be a from Windows Server Core because it's using Core for the base. And then I'm just running a few commands. So there's maybe 10, 20 different types of instruction on a Docker file. You can write perfectly good apps with a handful. So all I'm doing here is I'm saying I'm starting with my IIS. I'm going to install a Windows feature, which is .NET Framework, ASP.NET, and then I'm going to install the web version of the ASP.NET part. Then there's one little funky command that I have to write because Nerd Dinner has its own handler section, which by default IIS locks that down. So I can do like weird, clunky things that you wouldn't necessarily think you would be able to do. I can do anything that I can run on a command line. So I'm unlocking that section, and then I'm going to copy in the built website. So if you go into Visual Studio and publish your website, you're going to get all the binaries, all the views, all the content that goes with it, that sort of stuff. So that would be in my folder, the same place where my Docker file is. So when I build my image, it will pull that folder out with all the website, and it'll put it into the image in a known place. So then my expose is saying I'm going to run my app on a specific port, and when my container starts, it's going to be in an isolated environment. But that's no good if I want to actually be able to access the website. So the expose is I explicitly punch a hole in saying that when things try and talk through this port, they can.
So that is on the local machine, that port number's listening?
No, so that's in the container. I'm saying I will allow connections through this port. I'm allowing that. Not until I run it will I map it to a specific port on the host.
Okay.
So that's setting up everything in the kind of background. So the first few steps in the diagram we saw, and then I'm doing the final part. So I'm creating a new website. I'm saying which app pool I want it to run on. So it's the usual stuff if you were scripting all this stuff up or using something like DSC.
Yeah, if you're using a virtual machine, you'd run the same commands to configure.
Exactly. Yeah. So but some of the tools we've talked about today, like Vagrant and into the world of DSC and that sort of stuff, you have to put several things together because you have to start with a VM and then you go into something that will run your scripts for you and all that sort of stuff. This will be a single unit once it's built. And then we take away the default website because who needs that? Excuse me. And then one of the changes I've made is Nerd Dinner uses Bing Maps, and in the current code, the API key is baked into the code, so you have to put it in web config. So that's the sort of thing that's going to change per environment. It'll change on different developers, may have their own key, your test environment, your production environment, they're all going to be different. And you don't want to bake that into your code base. So the way Docker does that with images is to use an environment variable. So I can specify an environment variable here, which is like the default. But when I run my container, I can pass a flag saying my Bing Maps key should be this. So it's as simple as saying I've got a pre-baked set of config, but it's really easy to change because I can specify it at runtime. And if it's a secret like this or a database connection string, I can pass my environment variable to a file, and I can secure that file so only certain people can access it. So it gives you a lot of flexibility to do that sort of stuff. My entry point is just saying, because IIS is already a background service, if I try and run this through Docker, there's nothing for Docker to say, are you running? So you've got to have something running, which is my entry point there for PowerShell. So just going to start there, have PowerShell running, but in the background, IIS is going to do all the stuff. Okay, so there's a few more things in here, but apart from white space, it's still only 10 lines of code. And this is the point where dev and ops people can start coming together on this. So perhaps this would be a first cut from a developer who's got it up and running, but then you would sit with someone who's got more ops experience who would say, well, actually, we've got our own base image that is secure because we've nailed down certain things, or actually we don't need to install that feature because we can do it a different way. So this is somewhere where you can actually work together on a part of the problem, which is going to be directly the code that you run.
Yeah. Quite often when I'm talking about containers, people go, well, the developers will do all that. Where do we come in? But I think it's important that operations.
Absolutely, I think it's something that people don't really focus on, but the Docker file is the meeting point. I think the first place. Especially if it's fine if you're a startup and everyone can do everything, and that's great. But if you're in an established company, you are going to transition to DevOps. You're going to have established teams who maybe don't have a history of talking to each other nicely, and having something they can both work on is a really good focal point.
And just because it's code in Visual Studio Code, the same way as ARM templates, JSON in Visual Studio Code, doesn't mean it's just for developers.
Exactly. Yeah. This works on a text file. You can do it in Notepad if you must. So I only use code because you get color coding for the Docker file. But yeah, so it's a nice simple thing that people can get together and work around on and iterate over, because this would be part of your code base. It'll be checked in. So when you do your build and you produce your image, it will use the latest version of whatever you've got here. So like I said, I'm only kind of part way through this process, but I've got it up and running. So I've got a machine in Azure here. So in Azure at the moment, there's a Server 2016 Technical Preview 5 image with container stuff already installed on there. So this is just a VM from that image. If I run Docker version, we'll see some interesting stuff here. So there's three parts to Docker. There's the Docker, the kind of background service, which is called the Docker engine. There's the client, which is the Docker command line tool, and there's an API that sits in between. So actually, the API part is a really powerful because you can talk to it from different places. And the Docker command line is cross-platform, and it can work with any background service. So I could set an environment variable and talk to a different server that's running Linux and use the same set of commands. But I'm just running locally here, so it tells me which version I've got, which version of the API is running, and which architecture it is. So as we said, Windows containers currently have to run on Windows, Linux has to run on Linux. So in here, if I run Docker PS, I've got a couple of containers that are already running. So I've got my six-eyed Nerd Dinner web container, which is the image that I built from that Docker file that we just looked at. So it's got so as I was building the image, it ran all those PowerShell scripts, it copied in my website, it set up the website, all that sort of stuff.
So that would take a little while for it to run and install. IIS was already installed on your image, but take a little while to add the features
Yeah,
in the
yeah.
website.
Good point. So yes, it does, but Docker uses the images. I've said they're a logical unit. Actually, they're separate physical units. So each line in each instruction in a Docker file produces a different layer in the image. So what I've got is, I've got 10, 15 layers in there that when I say run, it will pick them all up and present them to the container as though you've got one file system, but actually they're separate layers. And the reason it does that is it lets me cache them. So if I go back to my Docker file here, if I just change this line and said actually we're going to leave the default website there, Docker, when I say do build, it'll look at the previous instructions and it will say, okay, we've already got all these, so I'll just get the cached version of here and then start running the changes in. So how you structure your Docker file is really important, because actually what you would really do is you would take your code and put that in last. So if all you were doing was changing code, it would only add in that one line. It'd be really quick. Excellent point, which I wasn't going to focus on actually. Yeah, so I've got my container up and running. I'm exposing one of that port. So from the container, I said, in the image, I said port 8081 is going to be available to use. And when I ran the container, I've said I want that mapped to port 80 on the host. So that's my open port. I've also got a SQL Server container running here, but that's, like I say, I'm part way through my transition, and actually the SQL Server stuff's not quite there yet. So you can create a SQL Server Express container. You can run in all your scripts that you would normally run, but at the moment, because technically we're in the kind of late beta, the networking part it doesn't seem to be working quite correctly. So we'll see what this. Let's
see what we've got. So that's running on port 80.
Yes, it's running on port 80. So I can run docker inspect. Each container gets its own virtual IP address within the host. So if I run docker inspect dinner web, it's going to tell me the IP address. So that's the IP address internally here for the container. So inside the container, it thinks it's running its own PC with its exclusive access to all the resources, because there's nothing else running in there. But from the outside world, we know it's an isolated unit. So on there, as it happens, I've set that to be my home page. So inside the VM, I can connect to that home page, that container IP address directly and look at port 8081, and that's going to give me the first part of it. So I know my key is working correctly because I haven't got a warning message from Bing Maps, so I know that side of it is all looking good. And I could, if I was connected to the SQL Server, I could go and navigate and look at all that stuff. That's going to be the kind of next stage. But also, because I've mapped it to port 80 on the host, if I were to browse to this Azure VM externally.
So there you were looking at 8081 because you were looking at the IP address of the container.
Exactly.
So now we're leaving that VM.
We're leaving that VM
local machine here.
back onto my local machine. So here's the public IP address of that VM, which I've given a friendly name, which I've forgotten the friendly name as well. And from here, I can just browse to that directly. So that's TechDays UK North Europe Cloud App, So that's just 80, so that's being served by my container. So when I make the request to Azure, I've got my network security group set up, so port 80 is allowed through. It hits the VM on port 80, and then Docker comes in and says, you've asked something on port 80, actually my container's on 8081. It routes the request to the container and relays back the response. So that's running in my container, in my Azure VM, the next step will be connecting up to the SQL box. So it's actually really straightforward to take an existing, what we're now calling a legacy app, and build it up into a Docker container. So it's not just for new stuff, it's for taking your old stuff and giving it new life.
And what if we wanted to, I'm not sure if you cover this later, if we wanted multiple containers to be running, that's just one container.
Yeah, absolutely, yeah.
If we've got multiple containers all using the same ports, multiple websites, how might we manage that?
Yeah, good question. So you can't have multiple containers running with the same port because they would interfere with each other. So Docker is aware of what's happening in the containers, and if you ask it for port 80, only one container can be mapped to that. So what you would normally do is you would have either a proxy in front saying, by domain name, so my xyz.com is going to map to port 5000 internally, and then Docker will route it for you, or and then port abc.com is going to port 5001 or what have you. So the proxy would sit there and do all that sort of stuff for you, which you might want or you might not, depending on what you're using your Docker host for. So that's the web Docker file. and looking at kind of taking an existing container, an existing app, and containerizing it. Dockerizing is the new verb. So that's what we've got so far. Really simple. I've got one container. I've set up my infrastructure so that I can map stuff to it. But actually, the interesting thing about Docker is it reduces your infrastructure requirements to a really simple set of primitives. I just need some sort of VM that can run Docker, and if I want lots of machines that can work together in a cluster, then I need to have some sort of network for them, and that's it. And then the rest of it can be taken care of by Docker. So that includes your applications, your monitoring. They would run as containers as well. And if you had scripts to do recurrent tasks, each of those would be a container. You just spin it up. So what we haven't got at the moment, which I will do hopefully when RTM hits, is our database connection. So the full nerd dinner has got a local DB SQL Server instance, which is not really what you want, because if you're doing that then you're having a huge disparity between development, test, and production. So devs using local DB, test might be SQL Express, and then production would be full SQL Server. You can containerize your database as well, and the interesting thing there is you remove some of the configuration headache, because in your containerized world, you have a Docker network, and your SQL Server instance running in a container will have a particular name, in this case DB. And so in your code, your connection string always says talk to DB, because it's always going to be there, because when you start your set of services, you'll make sure that your database container starts up with a specific name, and then your web container will always be able to find it. So it makes that stuff a lot easier. And when you start adding more and more things to it, then there's a whole bunch of stuff built into the Docker networking layer that makes it much easier to build really complex systems, distributed systems using the Docker infrastructure. So there's a DNS built in. So when you ping DB, then as long as you've created a container and called it DB, then it will be able to find it. There's a load balancer. So if you've got several containers running on different machines, all listening on the same port, because on different machines, obviously they can all have the same port, then Docker will load balance between them. So if you hit an external load balancer, and I had multiple Azure VMs, anyone could get the request, and it would be able to, Docker would poke it to the round robin to the next container. And Docker also has this excellent feature called the routing mesh. So if you have a cluster of Docker hosts, so maybe you've got 5, 10 machines all running up in Azure, all with Docker installed, you might have a few instances of a particular container running. So my nerd dinner container, I may have 4 or 5 instances running. And I can scale that up or down with a single command, because that's part of what you get with that Docker cluster called a swarm. But you might find a situation where I've got, say, 10 machines, I've got 5 instances of my container, so that means 5 machines aren't running a container. Yep. So, but Azure doesn't know that, because Azure is working, the load balancer works at the VM level. So a request comes into the load balancer, it will direct it through a round robin to any available VM, and that VM might not have the container running. But Docker gets the request for a service on port 80, it hits VM 10, VM 10 isn't running that container, Docker will reroute it to a host that is running the container. So Docker knows what containers are running on what hosts. That service called the routing mesh makes sure that it doesn't matter how many hosts you've got, how many containers are running, a request will get silently and intelligently routed to whichever host is running the container. So that enables you then to have a really complex infrastructure within the system boundary, so you can start breaking your app apart. So that's the kind of next thing. So when you've got your legacy app running in a container, you've maybe taken your test lab that's running in your data center. Maybe you've just got couple of VMs. So instead of deploying the next version of your app onto them, you install Docker, and then your next deployment is running Docker containers. Once you've got that set up, it becomes really easy to change the architecture of your system, because you don't need to commission new kit to make it happen. So in our nerd dinner example, we might find that we wanted to break out the home page. The home page will change frequently. We want to be able to change it and see what the impact is, and there's no reason why we should have to deploy the whole application to make that happen. So nerd dinner is a simple app, but if it were a big, heavy website, then we'll find ourselves with a couple of good candidates for breaking out into separate services. One might be something that changes frequently, where there's a lot of business value in being able to change it, like the homepage, so they can see, are we getting better retention with a different approach to the homepage. Another example would be something that there's business value in it staying the same. So like a checkout page or something like that, where it's complex, it's risky to change, but there isn't much value from the user's point of view because let's say the business know it works very well. So those are two really good candidates. I could take my 90% of my app and leave it as it is, and then I can break out the home page, run that in its own container, and the checkout component and run that in its own container, and then deploy those as part of my overall Docker network. So the only thing that's publicly available is my core website, and then it's communicating with those other containers inside its Docker network. So that's the way you then start breaking these things apart and saying, when we want to change the home page, all we're going to do is change that tiny component. We'll leave everything else as it is. If we want to break out another service from our main app, we can break out another service knowing that we're not going to break the checkout component because that's already been put somewhere else. So once you start bringing a container view of design into your application, then you can start leveraging some of that stuff that gets you to the point where you can change the things you want to change very rapidly with very low risk, and you don't necessarily have to. Not everyone is Netflix, and not everyone is Uber, and not everyone is going to have to change all their apps into 1,000 different microservices. I think there's a huge amount of value in saying we're going to take our app and we've identified 2 or 3 really key things that we want to be able to change quickly, and we're going to put those out into their own containers. And because we've Dockerized the overall app, it becomes sort of trivially easy for us to do that stuff. Likewise, if we were having performance issues, we might want to take a part of the workflow and make it asynchronous. So instead of having it sat there and a server listening, waiting for a request, processing a whole bunch of steps and then responding, we could drop a message onto a queue and then something else would come and pick that up later. Currently, if you wanted to do that, then that's a big architectural change. So hang about, we need kit now for the message queue. That's got to be reliable and durable. And then we need more kit to be message handlers, and they've already able to talk to each other. Because I've got my Docker machine, or my several Docker machines that already work together, I just run up a container containing my message queue, and another container to be a message handler. And if I've got more messages than I can deal with, I just throw more message handler containers at it. So it really is an enabler for thinking differently about your architecture.
Okay.
Cool, and then the last kind of thing which I've mentioned a couple of times is the swarm. So it's fine having my Docker machine, my laptop and my test machine and my Azure VM all running the same images, but what Docker also lets you do is take a bunch of machines and combine them into a cluster called a swarm. And that gives you a whole bunch of extra stuff. So it gives you the ability to scale, because I can say I've got my container running, I've got 5 instances of them across the swarm, and actually I want to have 10 now, or I want to go down to 1, and it will take care of that for you. There's a constant heartbeat between the swarm has a manager-worker architecture. There's a heartbeat between the workers and the manager, and if a worker goes down, then the manager will know, and it will see that there are containers that are not running in the swarm anymore, and it will spin them up on other machines.
So in a way, it's a bit like, with virtual machines, we had failover clusters. It's a similar sort of technology, I guess, but rather than virtual machines, it's monitoring containers?
Yeah, absolutely, yeah. So it's monitoring all those containers, and so when you create a container on a swarm, you give it a service level, and you say, I want 10 of these running, or 1 of them running, or I want 1 running on every host, and Docker will make sure that happens. So you don't have to do any kind of thinking about that. Creating a swarm is just a case of having a bunch of machines and running 2 commands. 1 command to start the swarm, and then on the other machines, another command to join the swarm, and then you manage it centrally.
And we talked about Azure Resource Manager templates a few times today, so you can actually go onto the Azure portal, and there is a template available. Just click through the GUI, and you can deploy a Docker swarm cluster with a few clicks on Azure.
Yeah, absolutely. So there's the Azure Container Service, which lets you create a swarm or an alternative type of swarm using Docker, which is called Mesos. And you can do that, and you can download your template, and you can tweak it and do whatever you want to it. So yeah, so you don't. I've been talking about creating stuff manually, but of course, in reality, you would have a set of templates that you use, or you would use a higher level service, and you get extra functionality there too. So when you've got a distributed system, you get into the world of container orchestration. So you need to make sure that they will start together, and they can all talk to each other, that sort of stuff. With Docker, you can build, as well as having an image for one application, which will run as a container, you can have an application bundle, which says, my application has got my web server, my database, my message queue, my handlers. They're all a single unit. So when I want to run it, I'll just tell the swarm to run that, and it will schedule it all around the swarm, so they've all got the level of service that you require. And then there's stage rollout, which is an excellent feature if anyone who's been involved in dangerous rollouts and having to roll back. So you can say, I've got version 1 of my app here, it's running on my swarm, it's great, it's fine, but we've got version 2 coming out now. And what I want you to do is do a staged rollout. So I want you to take down all the web servers one at a time and replace version 1 with version 2 and wait a few minutes in between and all that sort of stuff. So all that stuff comes for free. So just a couple of slides to see how that looks. So I've got my VMs within a virtual network so they can all talk to each other.
So these are virtual machines?
Virtual machines up in Azure. You can create them through your ARM template, or you can create them manually and just install Docker on them and create your swarm manually. And then when you tell Docker to run containers, it will put them anywhere. So it will look at the available memory, how much CPU is being used, and it'll put them on anywhere on the swarm, and you don't care. So this is getting to that whole pets versus cattle thing. So I don't know what my container is. It's got an IP address that I'm never going to see. It's got a name which is a huge GUID that I'm never going to look at. So all I know is I want 10 of them running, and the swarm is going to keep 10 of them going for me. If my swarm starts to be overloaded, then I just throw in another VM, and then I can schedule new containers on around the rest of the swarm. With Azure, of course, I can put an external load balancer on top of my virtual machine scale set or my individual machines, and I point my DNSC name at the external load balancer. So requests come into the load balancer, they get round robined, and then I trust the swarm to direct requests to wherever they need to go. And all that stuff is part of Docker now, and when Windows Server RTMs is going to be there for us Windows users too.
Excellent.
Yeah, so that's the kind of the final part of what I wanted to cover today. Really is the Windows container ecosystem is going to be RTMing soon. So you can run these containers. The containers I've been running are on Windows 10 and on Server 2016. There are slightly different variations. So the way containers work in Linux is part of the Linux kernel that's been around for an awfully long time. You could run a set of processes and kind of put them in their own isolated unit. And with Windows, you'll be able to do that too, or you can run them as a Hyper-V container. So you can run them as a Windows container, so it'll share the host kernel, the host operating system, or you can run them as a Hyper-V container and they get a tiny little thin VM and they sit on top of the VM, which kind of gives you the best of both worlds. So you can say, I've got a whole bunch of VMs here, a whole bunch of containers here that are they're not horribly secure. They don't have huge security requirements, so I can have those running as Windows containers and get the maximum benefit of having all the resources available to me. And these ones are going to be doing, whether they're doing monitoring or whether they're doing message pulling that's dealing with financial transactions or whatever, they're going to be in Hyper-V containers, so they have an added layer of security around them. When you run, when you fire up a Server 2016 or Windows 10, it's just a new Windows feature, Windows containers. And when you do that, you'll have a Docker Windows service sat in the background that's listening to, that's the Docker engine part of what we talked about earlier. So when you run your Docker commands, it will be listening to that on the Windows service. And then you fire up your Windows containers. So it's only Windows at the moment. So when you start playing with this stuff and you go to the Docker Hub and there are thousands of images, you can probably use only 1% of them.
Yeah, you need to be aware at the moment because the containers have been around on Linux for quite a number of years, and Docker's been around on Linux for what's it, 3 or 4 years now?
Yeah, 3 years. Coming up to,
so there's not so many Windows images, but what's the answer to that? Build your own.
Absolutely. So the really interesting thing, which we'll find out in a couple of weeks' time, is what the licensing looks like. Because one of the reasons why there are so many thousands of images is because Linux is free. So I can take my Ubuntu base image, add on a bunch of open source software, and make it public, which you can't do with Windows. So we'll see what the guys are doing in a couple of weeks' time. But those base images are on the Docker Hub, so you can use those and start building your own images. And we'll have to see what the licensing looks like.
I've been having some fun with some, I call them legacy applications, but applications that use in PowerShell DSC for state configuration. I've been building my images using the same PowerShell DSC that's been used on the legacy systems to create the images, but then once that image is created, you can go and use that anywhere, and that configuration never has to happen again.
Absolutely, yeah, and I haven't covered it here, but there's no, you can use PowerShell to make your images and run your images. You don't have to use the Docker command line. So Windows Containers is Docker compatible, but actually you can use PowerShell if PowerShell is your thing.
And of course, everything you've done, we could also automate through VSTS. There's
absolutely,
a couple of Docker extensions in VSTS that can be used to automate the deployment.
Yeah, so you get your image as part of your pipeline, which is where you want to be. So that's where we are. So we've got Ignite coming soon. We're going to have the launch of the new server, which will have all this stuff. I'm going to carry on with my transition of nerd dinner. So I'll be putting the SQL link in there, so you'll be able to have a container that's got your web server, a container with your database with a whole bunch of pre-baked test data, so that anyone can start that and start on a known state. And then gradually I'm going to do what I've been talking about, pick out key parts of it and run them as separate services. So I'll be tweeting about all that stuff. So if you're interested in that, then that's going to be happening soon.
That's excellent. And where can people go to find out more about containers and Windows containers?
So MSDN has got some great stuff on there. So there are some really good walkthroughs about if you just Bing for getting started with Windows containers. There's a Windows 10 introduction and there's a Server 2016 introduction, and those are part of the new documentation that's on GitHub too, so you can contribute to that as well. So yeah.
So if you find a bug in the documentation,
yeah, absolutely, yeah, or an enhancement, yeah.
Okay, that's great. Thanks very much, Elton. Now, before we wrap up, I just want to tell you about a couple of upcoming events. So Satya Nadella is making a trip to the UK on the 6th of October, so registration is open for the Transform conference now. I think the URL for this is AKA Transform 2016. You can see that there. So you can register now for Transform. If you want to find out more about Windows containers and Docker, I'm actually traveling around the country speaking at the Technology User Group. Let me bring that up now.
Trusting my
your history.
Yeah.
Sorry.
I should have cleared it out.
Going to come up. There we go. Yep. So Technology User Group. There's some events on here. I'll be in Manchester on Thursday, Newcastle on the 22nd of September, and Cardiff on the 29th of September, talking about Windows containers. If you want to find out more.
Fantastic.
So thank you very much for tuning into Tech Days Online, and thank you, Elton.
You're welcome.
Goodbye.